Welcome. So in this lesson, we'll begin to talk about calculating state matrices. So calculating any state matrix using recursion. So this should be a bit of a blast from the past from our financial component of this course. So we're going to be talking about recursion again. We can use a recurrence relation to model transition problems. For any recurrence relation, we need two components, the start point and the rule. For transition problems, our start point is defined as the initial state matrix and represented by S subscript 0. Our rule then incorporates the current state and the transition matrix. So here it is right here. And as you can see, this starting point, so S of 0, is our initial state and it's our starting point. So let's write here, it's our starting point, where we're beginning from. And then we also have our rule. So let's underline this and write that this is our rule. And what we're doing to find, our next state, what we do is we take our transition matrix, which is here represented by the letter T, and we multiply it by the previous state. And this will make a lot more sense once we dive into some examples here, but hopefully this is very much reminiscent of what we were going through when we were learning about recurrence relations. Okay. This allows us to investigate not only the resulting conditions at a given point in time, but also to assess whether the situation gets to a point where the values reach a steady state, even if the transition is applied again. And again, don't worry too much about that terminology. We'll be speaking more about a steady state later. Okay, and then finally, the initial state matrix, S subscript 0, is equal to the starting state of the system. So that is just a bit of definitions around what we're about to do, but don't freak out if you're still a bit hazy about this. Remember, things only start making sense once we jump into examples. So let's do that now.